This is Josh White with JW Math Tutoring. In today's video, I'm going to go through 10 problems from the March 2025 Digital SAT Math section. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I begin going through these March 2025 Digital SAT Math problems, basically worksheet and video number 3, please keep the following things in mind. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there will be a link in both the description of the video and in the pinned comment to a PDF file, which will have these questions that you're seeing on the screen. Third, so these are all self-reported questions that I've gathered mainly from Reddit. And thus, the thing to keep in mind is, I might be missing some specific piece of information in the question, or this version of the question might be slightly different, than the version that you had if you took the March 2025 SAT exam. So just keep in mind, questions might not line up exactly as one that you may have seen or may have taken, but I've done my best to try to make them workable and solvable, and try to gather as much information as possible. Where some people just kind of give bits and pieces in describing the question and not the full text of it. Related to that, most of these are going to be done as student-produced responses, i.e. free response questions, not multiple choice. However, if some of these questions were given as multiple choice, of course, you would have possibly additional solution methods that you could do that would be available to you when it comes to solving them. So just keep that in mind as well. All right, so with all that being said, let's go ahead and get started here. Problem number 1, again on this March 2025 Digital SAT Math question problem set number 3. Okay, so here we have a quadratic related question. And for this one, basically you have this equation. It's got constants in it, r and s and everything, and it tells you that the product of the solutions is equal to this expression rst. So this, if you know the formula for the product of the solutions for a quadratic equation, this question is actually very simple and very easy to solve, because the formula for the product of the two solutions is just c over a. So this is the c term, i.e. just the number term right here. And this is the a term, the number in front of the x squared term. So c over a is just rs over 3/5. And that is then equal to the rst. Now, first thing I'm going to do is I'm just going to change this, and I'm going to actually just move the 5 on top. So we have 5rs and then put the 3 on the bottom. And then again, you just set this equal to rst. R and s will cancel out, i.e. you can divide both sides by r and s. And so what is t equal to? It's just 5/3, and that's it. So you could grid in 5/3. You could also write it as a decimal, and you could truncate the decimal, or you could write it as a decimal and you could round it. So 1.666 or 1.667, all of these would be acceptable. Now, I will show you an alternate method you could use in Desmos. So what you would do is you would type out the full, just the function itself. We don't need to necessarily set it equal to 0. Okay. We don't need the y equals, but whatever, I'll just add it there. All right. Then we're going to add some sliders. Now, notice that currently, just when r is 1 and s is 1, there are no solutions. Okay? So since we're doing the product of the solutions, that means we expect to have at least exactly two real solutions. So you have to move these sliders in order to make sure it crosses the x-axis twice. So let's do this, and then right here, what I'm going to do is I'm just going to export both of these. Okay, so now I'm going to multiply my two solutions. So this is the product of my two solutions, okay? And this, let me just get rid of this, is equal to r times s times t. So I can just use regression and I can set this equal to RST, and notice it gives me the value for t right there, 1.666667. Okay? And you can just get it straight from that because it's taking the stored values for R and S above. So this is how you could do the entire problem in Desmos. And the thing is, again, you move R and S to different values, and then manually type in what the two solutions are, and you're going to see you're going to get the same value for t. All right, next up, let's look at the pool question. So this is number 2. This is the one where there is a rectangular pool, width of 11, length of 27. Okay, and there's a concrete sidewalk around it. So here is the sidewalk. Whoop. There, we'll just fix it like that, around the pool. Okay, so based on what various people had reported, I think the way that this question would be worded, like everyone mentioned the dimensions of the pool, say like 27 by 11, and I think what would be given is not the total area of the pool and the sidewalk, but just the total area of the sidewalk, i.e. the total area of the yellow part in the diagram. So that's, in this case, I just chose 168 feet. And they want to know how wide is the sidewalk in feet. Basically, this is x, in every dimension here. So you could technically split this up into 4 rectangles and then, find the area of all 4 of them and add them all together to an expression for x and set that equal to 168. I'm not going to show that method, but that is technically a way you could do it. Instead, I'm going to show what I think is kind of the more traditional or more common way. Which is to take the 27, which is the length, add 2 x's to it because it has an x on either side. So this is the total width from here to here. And then take the 11 and add 2 x's to it, which again would be the total distance from here to here. When you multiply those, that gives you the total area of the pool and sidewalk together. And that's just going to be equal to 27 times 11, which is the pool, plus the 168, which is the sidewalk part. So now for this equation, you can just go ahead and solve it out, or you can literally just, basically go straight to Desmos. So let's just go to Desmos and solve it in there. Delete this. Wait, no, get rid of this. Okay, so notice here it gives me a value of x1 equals 2. There are technically 2 solutions. This is the quadratic. So if you FOIL out this entire left side and then you multiply this out and you add it to the 168, which is 465. That's the total of both of them together. I'll just tell you the final quadratic you end up with is 4x squared plus 76x minus 168. And then when you factor it, it becomes 4x plus 84 times x minus 2. And you get x equals 2. So, and that is the correct answer, which is 2. So in this case, it would be letter A. Now, you could also, technically, since this one was mentioned to be multiple choice, you could also do this by back solving. So you could just take the value for x and you plug it in and say, okay, so this is 27. If it start with 2, if it's 2 feet on either side, that would mean this is 31. And then the other way, it would be 15. And you do 31 times 15. And you see, does 31 times 15 equal 27 times 11 plus 168? If it does, which it should, then we have the correct answer. If it does not, then you could go ahead and move on to answer choice B. So let's just confirm. 31 times 15 is 465. 27 times 11 plus 168. Yes, 465, we get the same value. So that just confirms that it is answer choice A. But again, that's an alternate approach of basically back solving, where you start with the answer choice and plug it in, and then basically you're going to match up, the total area from two different calculations. All right, next up, let's look at question number 3 here at the bottom of the page. So here you have an expression, basically it's a rational function. They tell you that this graph does not touch the line x equals 3. I don't know if that's the exact wording they used on the test. I mean, that's what people mentioned. But in any case, what this means is that there is a vertical asymptote. So if you graph this out at x equals 3, there will be a vertical asymptote. The graph, whatever, would look just hypothetically something like this. So that means that the denominator basically is going to equal 0 when x equals 3. Meaning that when you plug 3 in for x, you get a 0 in the denominator. That's basically what causes this does not touch the line situation, i.e. vertical asymptote, to happen. So you plug in 3 for x, and 6 plus c equals 0. So that's how you know that c equals -6. All right. Now, from the numerator part, so you got 2x, minus 6 on the bottom. They tell you that both f of 7 and f of 8 are zeros. So there's multiple ways that you could do this. What I think is the easiest way is just to notice, okay, well, if they're both zeros, then that means, since this is a quadratic on top, it's got to be x minus 7 times x minus 8. Because, these are our 7 and 8 are our two x-intercepts. Our two zeros, two roots. So you multiply this out, you get x squared minus 15x plus 56. So we've got, obviously here, this is just 1, and notice that matches. But then this is technically our a value, and this is our b value. So a plus b plus c should equal -15 plus 56 minus 6. So we go ahead, we add all those together, and you should get 35. So the correct answer for this problem that you would grid in is going to be 35. Let's just confirm. -15 plus 56 minus 6. Yep, 35. All right. Now, could we do this in Desmos? So I believe that you can get the a and b values in Desmos, but for c, that I don't know that there's necessarily any easy way to do that in Desmos. I believe you are going to still have to know that when you plug in x equals 3, basically it makes the function undefined, i.e. the denominator is equal to 0. So this I think you still have to find manually. But let's say you did that, and then you could just make a table. All right, and then we could put in the function. So we're going to have x1 squared minus a x1 plus b, and then divide that by 2x minus 6. Okay, so notice here, okay, it's giving me, let's see, oh, this is the reason. I was going to say it's giving me the wrong a value, but it's because I typed a negative instead of a positive. So always double check, make sure everything is typed correctly. This should be plus here. Now, a plus b, and then technically for c, we would have to do it manually here and, type in -6. Unless you wanted to just make this c, and you would, in a separate line, just say c equals -6. You could, of course, do that as well. But in any case, that's how you could do regression, just to find the values for a and b in Desmos. All right, let's talk about number 4. So this one is a problem that's a bit unusual. Basically, it's describing a situation, and you have sort of a system of an equation and inequality together. So the first part, 2 school districts have a total of 7,000 students. So, okay, that's easy enough. That's just going to be x plus y equals 7,000. You know, school district 1, school district 2, total, add them up, 7,000. All right, that's in all the answer choices. Okay, move on to the next part. This is the tricky part. The difference between their enrollments is no more than 5,000 students. So what that means is, you know, you subtract one minus the other, it's going to be less than, not 5,000, sorry, 500 students, excuse me. If you subtract the difference in their enrollments, it's going to be basically less than 500. But the problem is, you don't know necessarily which one has a larger enrollment, X or Y. Like, that's not specified in the problem. So really, this part right here, this difference in enrollment part, no more than 5,000, this is essentially an absolute value inequality that you set up like this. The difference in the enrollment is no more than 5,000. And this accounts for the fact that like X could be the larger or X could be the smaller enrollment. Because when you break this down, when you set up the two things, essentially what you end up with is this compound inequality right here. Basically, it's going to be from negative 500 to positive 500, the difference in their enrollments. That's what the subtraction's for, difference. And it's going to be positive if X is the school district with the larger enrollment, but it would be negative if X has the smaller enrollment. So the correct answer for this one is going to be letter C. All right, next up, question number 5. Here you have one where you have the equation of a circle, you're given its radius, you're asked to find the value of t. So a couple things to mention about this. First, this was reported as a multiple choice question, at least where I found it. It had, the problem, and then it also had 4 answer choices. But none of the 4 answer choices listed matched this equation and this radius which were given. So I'm going to solve this as a free response question. I'll talk about another method you could use if it was actually multiple choice just at the end. So first way you could do this, free response, call it like the traditional way, is to go ahead and basically complete the square on both the x and the y terms. So I'm going to add some blanks. I'm also going to move the 69 over to the right and put 2 answer blanks with it. And then for completing the square, we take half of the b term. So in this case, that is root t. This is technically the coefficient. And then we square it. So when we square it, notice we get t over 4, right? The root and the squared cancel out, 2 squared 4. Okay, so I'm going to add that over on the right. Now, same thing for the y. It's a negative 1 in front here. Divide it by 2. And then square it, and you get 1/4. So I'm going to add 1/4 on the left and on the right. All right, now focusing on the right, we have basically 69 and 1/4 plus t over 4. Okay, this value, all these things added together, are equal to r squared from the standard form equation of a circle. So we take this radius, which is root 86, and we square it. We just get 86. So in other words, we're going to set all of these equal to 86, and that's going to allow us to solve for t. So again, the equation is basically 69 plus t over 4 plus 1/4 equals 86. I'm just going to go to Desmos to do this because of the fractions involved. So and I'm just going to do this with regression, so I can just keep it as t. All right, so right there, t comes out to be 67, okay? So that is the correct answer. If it was multiple choice, that would presumably be one of the answer choices, but it was not one of the answer choices. That was given. So next thing here, if it was multiple choice, okay, I'll show you how to do this first, and then lastly, I'll show you how you could actually do it in Desmos using regression. So if this was multiple choice, all you would have to do is you would take the equation and type it in. I'll add the slider for t in a second. I'm going to move the 69 over to the right. Okay, now I'm going to add slider for t. Let me move this over, zoom out. Okay. So here's our circle. What you want to see now is the radius of this circle equal to square root 86? Okay, so basically we need these 2 points. Specifically, we need the y values. The x value is irrelevant. And we're going to, or actually no, what we're going to do is we're going to find the distance, just use the distance formula, find the distance between them in general. So 9268, comma, negative 8.77362. Okay. So this is the distance between here to here, which is the diameter of the circle. Okay. So to get the radius, I just have to take this and divide it by 2. Nope. Gonna go outside. There we go. So now the question is that equal to square root 86? And yes, it is. Now, it's obviously not exact because these point values aren't exact. They're rounded off. But you can still see 9.2736, 18, which would round to 0.62. So this matches, this confirms it's correct. If you tried like any of the other answer choices, like for example, the answer choices that were given for this was like 71, 73, and some other things. Like if you tried, for example, 71, if you notice here, the numbers are slightly different. And so let's just see 21307. 21307. 21307. Okay. Now let's check the y values. 82738. And down here, 82738. Okay. So now I have the distance between them, and I've already got the divided by 2. So the radius length is 9.32, 9.33. But the square root of 86 is 9.27. So these do not match. So that tells you that 71 is not the correct answer. So this is a method you could do if it was multiple choice. Now, lastly, I will show you how you could do this using regression. So what I would do is I'll type in the original expression, and I'm going to have to change it, all the x's and y's to x1 and y1. Then I'm going to do standard form regression equation of a circle minus, now it's minus r squared, and r squared, of course, is 86. So, okay. Now I need to define a list for x1. I need to define a list for y1. And look, just from entering 4 values for x1, 4 values for y1, I get some nice, easy to work with answers right here. T equals 67. Okay, so this is how you could get the answer just solely using regression. The key with circles also is to choose some different values. Like, don't choose the exact same values for x1 and y1 because then it takes a lot more points, a lot more elements in the list. But here I chose 1, 2, 4, 5. Here, by choosing just 1, 3, and 5, 3 is not in the first list. That's what allows me to get it with only 4 elements in one and 3 elements in the other. All right, next up, let's look at question number 6 at the bottom of the page here. So here we have a quadratic expression. And the way that you would do this by hand is first we would distribute this x out. Get 14x squared plus 15x. And then plus c and subtract the 9 over, minus 9 equals 0. Right? Then you would basically set up the quadratic formula, because that's basically the form that this solution is given in. So you've got negative 15 plus or minus 2 times 14. Notice that matches the 28. Okay, plus or minus, here's the important part. B squared, which is 15 squared minus 4 times 14 times c. And here c is technically this entire expression of c minus 9. So essentially what you're doing is you're setting this whole thing equal to 113 and then solving it. So it's just 225. This is negative 56. So you can make this negative 56c plus 504 and then equals 113. And if you solve this out, and I'm just going to go to Desmos to do this, you should get c equals 11. And note, I can actually start with the whole thing. Again, I'm just going to use regression. Minus 4, negative 14, c minus 9, tilde 113. No, I get 7. Why? Oh, it's positive 14, not negative. There we go. Double check, yes, positive 14. Okay. So you can just type this whole long thing in, use a tilde instead of an equals, and it'll tell you that c equals 11. All right, so that is the correct answer for this one, letter C. Now, if you want to do this entire problem in Desmos, here is how you could do it. So what you would do is you would type out this original function. Okay, and we're going to actually use we're actually going to do regression, so I do need to make this a tilde, not an equal sign. All right. Now, what I'm going to do is I'm going to tell it that x1 is equal to that number that is provided. So the negative 15 plus square root 113 divided by 28. Notice now it basically takes that value and it plugs it in for all the x's in this regression statement, and it gives me the value of c, which makes this true, which is 11. So this is how you could do this entire problem, basically in 2 lines in Desmos. Next up, number 7. This is a repeat question. This has appeared on previous multiple tests in 2024. So you have an exponential function. You're given 2 values here, and they want to know what's the value of f of 8. First, I'll show you the theoretical way to do it, and then I'll show you how you could also do it in Desmos as well. So the theoretical way is, I think it's easiest to think of this, in a table, right? So f of 5 is 7. F of 7 is 175. So the way an exponential function works, right, is to get from each y value, for each 1 unit increment in x, the y value is just multiplied by something. For a geometric sequence, which is essentially what this is, it's called the common ratio. Essentially, it's the b value here. So, like, you have 7, you multiply by b, and you get whatever, the y-coordinate for 6 would be. And then you do it again, and you get the y-coordinate for 7, which is 175. So, essentially, 7 multiplied by some number twice, i.e. squared, is equal to 175. And you just go ahead and solve this. You divide by 7. Again, this you could also do in Desmos, just do regression. And you get b squared is 25, or b equals 5. So now, that means to get 8, we're just going to have to multiply the 175 times 5 one more time, and that should be 875. So let's just confirm this. First of all, solving the original equation, 7b squared tilde 175. Yep, b is 5. And then, of course, we can just take 175 times 5. And there it is, 875. Okay, so that's kind of the theoretical explanation behind it. However, if you want to do the entire thing in Desmos, here is how I would do it. So I would pick 5 and 7. I pick 7 and 175. Then I'm going to do a regression statement. Now, here's the problem. You have A, and you have B, and you have N. So you have 3 values here, but only 2 points. What we need to do is technically define N as some number. Let's just say N is 1. And then that gives us what is actually the correct value for A and B. So you can't put all 3 in. You can't put all 3 constants A, B, and N in and expect to find the correct answers. You have to substitute something for N in. And then, now, multiple ways to find this. You could just do, you could just type f of x equals ab to the x over n. And then you could say, what is f of 8? And right there, it's 875. And now what you're going to notice is, as I move the slider for n, even though the b value is changing, the f of 8 part does not. So notice, even as I change n, which results in changing b, the f of 8 part is still staying the same at 875. So that part doesn't matter. It's irrelevant. You're still going to get the same answer regardless of what you pick for n, as long as it's a positive number. All right, next up, let's look at question number 8. All right, so this one, person had provided a nice diagram, nice picture for this one. And I'm not sure exactly what was given because there were only 2 sides labeled in it, so I'm sure that, this might be a little off from the way that the question was provided or worded, but you have something like this, where you have a right triangle, okay, ABC, B is the right angle. One side is 18, one side is given as 33, and you also have the altitude right here, which splits it into 2 smaller triangles, and of course everything is similar to each other. Right here's point D. What's the ratio of BC to BD? So, if you're familiar with similar triangles, it turns out this question is actually quite simple. It's just going to be 33 over 18, okay? And the reason why is because in this small triangle here, okay, BC is the hypotenuse, and BD is the shorter of the 2 legs. So it's basically like hypotenuse over what looks like shorter leg based on my picture. If you look at the large overall triangle, 33 is the hypotenuse. So because, again, these triangles are similar, the corresponding parts are proportional, which means that they match up. So BC is the hypotenuse. That corresponds to AC, which is 33. And then AB, the shorter leg, right here, in the overall triangle, corresponds to BD. So it's basically just 33 over 18. And if you weren't sure about that, again, these are just made-up angle. I'm just using like made-up angle measures just to, for the purposes of this demonstration. I'll show we'll get the actual angle measures next when I show an alternate method to solve this. Basically, what you can do is, right, if you look at the large overall picture, here's A, here's B, here's C. Okay, here's a 50, here's a 40. If you take this triangle and you match it up in the same direction, so D is where the right angle is, okay, B is up here at, B is at, wait, this is not right. What am I doing here? This is labeled incorrectly. Sorry, if I label this at the top 50, then this obviously has to be 40. And if this is 40, this right angle has to be 50. Okay, B is up here at a 50-degree angle. So that has to correspond to A, which is also 50. And C is down here at a 40-degree angle, which corresponds to, well, C, because that's also 40. So now you can easily see BC corresponds to AC. And BD corresponds to AB right here. So BC over BD, 33 over 18. All right. Now, with that being said, here is an alternate method you could use involving, trigonometry if you're not that familiar or comfortable with similar triangles. I mean, it's a bit longer and it's going to be a bit more work. But here's how you could do it. Let's just draw this up here. All right. So what you have to do first is you have to find one of the measures of the angles in this triangle. Okay, so let's start with A. Basically, I know that the cosine of A is equal to its adjacent over its hypotenuse. So 18 over 33. So let's go to Desmos and find that out. So I'm going to call, so angle A is arc cosine, inverse cosine, 18 over 33. All right, now I can already tell this is wrong because it's not giving me a degree measure, so let me just switch. There we go. Also shrink this down a little bit. All right, so that's what it is. It also means that C is equal to 90 minus that. All right. So now you need to find BD and BC. So the way you can find BD is, first you can look at the small triangle here. So just looking at this triangle, We know this angle up here is 56 point something. So we can say, all right, the sine of this, sine of A, is equal to BD over 18. Or in other words, BD is equal to 18 times sine A. I'm just going to call that D in the in Desmos. So again, drag this down. That's just going to be equal to 18 times sine A. All right, so now I have that value, and I have the exact value, so that when I go to set up the ratio, it's not going to be an issue. All right, so now that we have that, we have this side length. For BC, you can just technically do Pythagorean theorem, okay? So 18 squared plus BC squared equals 33. So that we can just go to do in Desmos. We're going to get the exact value for that as well. I'm just going to call that C. Actually, no, I can't call it C because I already called angle C. Let's call it lowercase c. All right, so now we have the length of that. So capital D over C. BD over BC. That's what we're looking for. No, we want BC over we want the opposite. So we want C, lowercase c, over capital D. All right, and so there's our answer. So notice, if you switch it to this, I mean, 33 over 18, yes, can be simplified or reduced to 11 over 6, but you can also give 33 over 18 as an answer. So 33 over 18 would be acceptable. 11 over 6 would also be acceptable. Or you could give 1.833 as well, if you want to give the decimal form. All three of those would be correct, but this is how you could do it using basic trigonometry to find the length of BD, and then Pythagorean theorem to find the length of BC. Again, it's a lot more work than using similar triangles, but if you are stuck and don't have any other method, you can still figure it out that way. All right, let's look next at number 9. This is a repeat question. This appears on the Blue Book practice tests. So it has also, though, been reported to appear on official exams, so we're still going to go over it. Tom is painting this room. Total area of the room is W square feet. 1 gallon of paint will cover 150 square feet. Which of these represents the number of gallons that he will need to paint the room twice? Okay, so one way to think about this is doing unit conversions, which is to say, okay, 1 gallon will paint 150 square feet. Okay? Tells us that in the problem. Then, how many square feet does he want to paint? Well, the total area of the room is W, but he wants to paint it twice, so that means it's technically 2W square feet. So now these units cancel out. The 2 and the 150 become 75, and you're left with just gallons. And specifically, you're left with W over 75 gallons. So the correct answer to this is just letter B. All right. Now, here's an alternate method or approach you could take. This is basically picking numbers. I'm going to say that the total square feet in the room is 150. All right? So if he wants to paint it twice, then the total area is going to be 300. And if each gallon covers 150 square feet, well, he's just going to need 2 gallons. So now we just run through these answer choices, and we see when we plug in 150 for W, which of them is equal to 2, the number of gallons we're looking for. So answer choice 1. First, I'm going to just set W equal to 150 right here, and then I'll just do W divided by 150. That is 1. That is wrong. W divided by 75. That is 2. That is correct. 150W, clearly not correct. 75W, again, not correct either. So that's just an alternate approach you could take using picking numbers just to confirm the correct answer is letter B. All right, let's look at question number 10 here, the last question on this March 2025 problem set number 3. Here you have a function, and basically we want to factor it, and we just want to know which of these constants in the in the various factors has the smallest value. So first thing you should notice is that we have a common factor of 2x we can pull out, and that would give us x squared plus 19x plus 88. Now we are looking for, it's going to be x and x, both going to be positive. We're looking for factors of 88 that add up to 19, so those are just going to be 11 and 8. So now it's completely factored. What's the smallest value of b? So notice we ignore the 2x because that's really like 2x plus 0, but it tells us in the problem b is a positive integer constant. So b cannot be 0. So we ignore that for these purposes. So we're really just looking at these two right here. So what's the smallest value of b? Well, it's just right here, it's 8. 8 is smaller than 11, so the correct answer for this one would be 8. Now, I will show you, you could also just go straight to Desmos, and you could graph out the function, and then look at the the x intercepts, and then you just have to know how you basically convert an x-intercept into a factor. Let's zoom out. Okay. So we got one here, we got one here, we got one here. All right, so the basic idea, the basic property is whenever you have an x-intercept, say it's like the x-intercept value is c, the corresponding factor is x minus c. So if you look on this, we have, well, 0, again, we can ignore because it's not positive. You have negative 8 and you have negative 11. So the corresponding factors are x minus negative 8 and x minus negative 11, which turns into x plus 8 and x plus 11, and therefore positive 8 is less than positive 11. So that's just how you could get the answer from Desmos as well. All right, so I hope you enjoyed this video. Of course, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. If you have any alternate solution methods or comments or questions, please leave them in the comments section below. Otherwise, be sure to check out the videos of the other worksheets or problem sets from this March 2025 digital SAT math exam. And lastly, if you are looking to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It features over 3.5 hours of tips, tricks, and 45 practice problems to help you ace the digital SAT math section using Desmos.